This morning, the kids looked at iron, one of the most abundant metals on Earth and throughout the universe. Next, the scientists want them to get to grips with another common interstellar ingredient. It's found on Earth as crude oil, and it's vital to humankind.
Now, what is oil? What is it? Anyone?
Oil.
No, what is it? Yeah, what?
Is it made from metal?
No, hydrogen and carbon. It's called a hydrocarbon. Okay, these contain carbon and hydrogen only. This is how it comes out the ground, but notice that it's really, really thick. This is a mixture of all sorts of different hydrocarbons.
Crude oil was formed up to 300 million years ago from the remains of ancient plant life. Because it's made up of lots of different hydrocarbons, Peter's using it to help the kids understand how different combinations of the same element, in this case hydrogen and carbon, can produce different properties.
So these are molecules made up with carbon and hydrogen only, but they have all sorts of different lengths. But we can separate these out.
Industrial distillation splits crude oil into different-sized hydrocarbon molecules. The longer the molecule, the heavier and thicker the resulting product. The heaviest, bitumen, is used to tarmac roads, while lighter ones like kerosene or petrol are used for fuel.
The easiest ones that come out, they're really very thin and runny. Okay, so these are used for airplane fuels. And then as you go further down, they're getting thicker and less runny. Now we're going to set fire to these, and we'll also see that we want to see which order they're burning. So which ones do you think are going to burn quickest? The heavy ones or the really light ones down here?
Light ones.
Yeah, exactly. So let's try the experiment then.
There are 6 fuels, each made from different-sized hydrocarbon chains. From larger to smaller they are engine oil, diesel, kerosene, jet fuel, aviation fuel and petrol. To compare their burn rates, lengths of rope have been soaked in each fuel with a small explosive rigged to go off as soon as the flame reaches it.
OK, so we're going to start with the black oil.
The molecules of black or engine oil are so large and heavy it's incredibly slow burning and produces lots of carbon smoke.
Let's have a look at the diesel.
Diesel is also made up of larger hydrocarbons.
It's burning quite slowly. So we're going to light the next one. We're going to light the kerosene.
Lighter fuels like kerosene are much more flammable because their smaller hydrocarbon molecules mix more easily with the oxygen in the air.
OK, it's burning a lot quicker and it's got less smoke, so not so much carbon coming off it as it burns.
So which one's going to make it first?
Oh, diesel.
Jet fuel has a similar burn rate to kerosene, but some hydrocarbons are even faster.
And we're just going to move on and look at the petrol and the aviation fuel. Now, which one do you think will burn the quickest out of those two?
Which one burnt fastest? Petrol!
To demonstrate just how fast petrol burns, the scientists have one last and very loud demo lined up.
Chris, can you light the petrol, please?
50 metres of petrol-soaked rope plus a golf ball-sized amount of plastic explosives is the perfect end to the day.
Bang!
The bucket's gonna come back down here.
Where's the bucket?
I don't think there is any bucket anymore. That's just a tiny little bit of C4 explosive.
Yeah.
And they were saying, "Where's the bucket gone? Where's it gone?" You know, and here,
There is no bucket.
there is no bucket.